Hello everyone, welcome to my fifth LinkedIn Live session, where we are diving into C# concepts. Today's focus is on inheritance in C#, but we will also touch on covariance, contravariance, and generics in programming. Okay, let's take a quick look at what we will cover today. First, we will dive deep into inheritance in C#. What is it, how it works, and why it's so powerful. Then we will explore covariance and contravariance in the context of generic. And next we will compare generics in C#, Java, and C++ templates to see their unique approaches. And finally, we will code together in Visual Studio Online. So let's get started. Okay, what is inheritance? Inheritance is one of the cornerstones of object-oriented programming, and it allows a class to inherit properties and methods from another class, which we call the parent or base class. Let me show you a quick example. Here we have a class, animal, with a method eat. The dog class inherits from animal, meaning it gets the eat method for free. Additionally, dog has its own unique method, bark, and this simple relationship is what makes inheritance so powerful. It promotes code reuse and makes programs easier to manage. Okay, types of inheritance in C#. Inheritance comes in different types. Single inheritance is the simplest form, where one class inherits from another, and multi-level inheritance creates a chain like a puppy inheriting from dog, which inherits from animal, and hierarchical inheritance is where multiple classes share a common base class. C# doesn't support multiple inheritance like C++, but it offers interfaces to fill that gaps. Method overriding brings polymorphism into play. In C# we use the virtual keyword in the base class and override in the drive class to redefine behavior. Take a look at this example. Animal has a speak method that outputs a generic sound. Notice how we are treating an instance of dog as if it's an animal and yet it speaks like a dog. This is polymorphism in action. And access modifiers like public, protected, and private control what members of a class are visible to its drive classes. For example, public members are accessible everywhere, and protected members are only accessible within the base class and drive classes. And the private members are hidden and can be accessed by derived classes. And using access modifiers effectively ensures we follow encapsulation principles while designing our classes. And this is a code. Abstract classes and inheritance. Abstract classes allow us to define methods that must be implemented by derived classes, ensuring consistency. For example, in this code, the animal class has an abstract method, speak, which means every class inheriting animal must provide its own implementation of speak. It's a great way to enforce design contracts in object-oriented programming. And sealed classes and methods. Sometimes we might want to prevent further inheritance. That's where the sealed keyword comes in. If we mark a class as sealed, no other class can inherit from it. And similarly, if we mark a method as sealed, it can be overridden in a drive class. And this gives us a fine-grained control over how our code is extended and protects our design when necessary. Okay, about covariance in C#. In C#, IEnumerable is a generic interface used for representing a sequence of elements that can be enumerated or, in simpler terms, iterated over. The key point about IEnumerable is that it is covariant, which means it allows us to assign an IEnumerable of string to an IEnumerable of object. And this marks because strings are objects and covariance lets us treat a collection of strings as a collection of objects. Let me explain with an example. Here we have a list of strings, which is assigned to IEnumerable of string. And since IEnumerable supports covariance, we can further assign this to IEnumerable of object. Notice how we then loop through the collection using a for each loop, and everything runs smoothly because the runtime understands that strings are compatible with objects. Covariance is particularly useful when working with methods that return collections of types in inheritance hierarchies. And our next slide, here is an example about contravariance. We have two classes, animal, which is the base class, and dog, which inherits from animal. There's a method called processAnimal that takes an animal object and simply prints a message. We first assign this method to an action of animal, which represents an operation that processes animals. Then, thanks to contravariance, we assign this action of animal to action of dog. And this works because a dog is an animal, and contravariance allows using a more general type where a specific one is expected. Finally, we call the dog action with a dog object, and it runs without any issues. Okay, we explored how inheritance simplifies code reuse and promotes flexibility, and we discussed abstract and sealed classes that gives us more control, and we touched on covariance, contravariance, and the differences in generics across C#, Java, and C++. Now let's see these concepts in action. So let me open my Visual Studio. Here I have created a project before my presentation. And here let's start by defining a base class named animal. And this class will serve as the parent class in our inheritance hierarchy. And so let's create this class here. Public class animal. And inside this class, I will define a protected method called speak, for example. And the protected keyword ensures that this method is accessible only within this class and its drive class. So before this method, let me create some properties. I want to create name property for this animal class. So it should be string and name. And let's create another property. I want to create age property for this class. And now let's create our method. So I want to use a protected keyword. We don't have any output and returns. and I want to call it speak method. And here in a speak method, I want to, for example, log something, and I want to log this. For example, this name is speaking. Okay, now let's create another class. I want to create a derived class called dog that extends the animal class. And this demonstrates how we can use inheritance in C#. So let's create our class. Public class dog. And it inherits from animal class. And here is our subclass. Notice that I haven't added any method or properties yet. This class will inherit the behavior and all property and the method from the animal class. So let's see the result. And inside the main method, I will create an instance of the dog class. So dog equal new. Here I want to fill the name property, for example, Tila, and age property to 7. Here, if I want to see the property of and the method, here you can see we have access to name and age, that these are the properties of animal class and we don't have them in dog class. So as I mentioned, dog class is inherits from animal class. So because of that, we can have access to all its property and the methods of the parent class. But here we don't see the speak class. And it's because of this protected keyword, because the access modifiers of this method is protected, so we don't have access to this method outside of the class, and we can have access to it just in our subclasses. And here I can change a speak class, but before that I want to add virtual keyword, to this class, because this virtual keyword allows us to change its body to the subclasses. So here we use protected override void speak. And here I want to change the body, and I don't want to run the parent body first. So in this class, I want to set, for example, right, because it's a dog class, barks. And here I want to run the application, but before that, because I want to see the result, I change this protected to public, that we can have access to this method here in main. So here I can use a speak method too. Let's go out. Okay, as we expected, here it prints Tila barks, because Tila was the name that we assigned to its name property, and this body is running because we override the body of the speak method of the parent class to our subclass. And if I remove this, okay, let me comment it and run the application. Here we can see it prints Tila is speaking, because this body is running, and we didn't overwrite anything here. So because of that, we have to see this. Okay, this was my presentation, and thank you all for joining me today, and have a nice day. Bye, everyone.